Hello everyone, my name is Syed Amjad Hussain Zaidy and I work as project engineer at Turbulent Flux. Today I would like to show you how as a user you can use Flux Applied to optimize gas lift rate for maximum oil production in a well. We will use different modes available in Flux Applied. First, this is the main page of for the login. We just log into the system. When we log in, we will be able to see all the assets available. We have already explained some of the basic things about Flux Applied in one of our previous videos, so I will not be going into many detail, but I will just navigate and go to there and focus on the main part that we want to focus in this video. For the purpose of the video today, we will be using these demo-gl. Once you go inside, you will be able to see different revisions, and each revision basically represents changes to your model. So you starts with revision 1, and when you change your model, you can save it as revision 2 if you want. We go to revision 2. Once you go inside a revision, it will give you some information about the revision itself or the model. We can see trajectory. It can be a pipeline, but in this case it's a well. We can see different equipments. For instance, we have reservoir contact, we have gas lift source for this particular well, we have a choke, for instance, and if for some reason we want to edit the base case, then we simply go into edit base case. When we go into edit base case has different tabs on the left hand side, and all these tabs can be used to for the different types of inputs. For example, in trajectory, we put the trajectory, material definition, and all this information that we put in these tabs is converted into a JSON text, which is then used as input to the simulator when we run the simulations. This base case runs fine. We have already run it and tested it. Now we go back on the revision 1 page. On the revision 1 page, we will be looking into these different modes, run modes. To add a new run mode, if we click on this plus button, and this drop down basically shows us what are the different types of modes available. We can define a name, description if we want, it's optional, and then simply add it, but we have already added, so we don't need to add. Here we have 3 modes. The first one is scenario, the second one is parametric, and the third one is optimization. Let's go to the first one, which is a scenario. In the scenario, basically it allows the user to define time series on different components of the model. Here under the parameter, if we click on this drop down, it is showing us that these are the components that are available where we can define time series for. There is one that is highlighted, and we have already defined a time series for this one. If we click on this one, then it appears, it shows what we have defined. I have defined a time series. Here we have time in seconds, and then we have value as it's changing over time. On the right hand side, we can see the same in a trend plot, and all this is converted into text. If we go into the text editor, which is when we run the simulation, this is used by the simulator. We also have this possibility that if for some of the rows it's okay, we can define it here, but if it's too much, we can make use of in the form of CSV. We can import it directly here into Flux Applied. We have test run. It is basically to once you are complete with your configuration defining different time series, you can simply run it here and check if the model is running fine. But for the basic running of the simulations, we use these simulations under run simulations. So I have already run the case. As you can see, it was run on 24th of June, and the variables are available to be plotted. So what we can do is we can plot there are many variables to choose from, but what we want to see is how this changing gas lift rate is affecting the oil rate. So we can plot it. So we have before we look at the results, so we have on the x-axis we have time, which is the local time on your machine. It basically goes for, we have run it for it basically the start time and end time. So it basically takes what is the start time when you have local time when you have started the simulation, and then on the top it adds the time, the end time of the simulation, as we can see here. On the y-axis we have volume flow oil at standard conditions. This slider, it's that if we want to plot trend data for different positions, so it starts from 0, meaning that starts where the reservoir contact is located, and then if we move the slider, so we are changing at different positions. So the last one towards the end, it's the wellhead. We will have to change the scale on y-axis, so I will, let's do 0.01, and then we also change the maximum, so 0.025, something like this. It's more clear now. You can also change it here underneath if you want to. So what I did here, we can also do it from here and press the apply button. So the point is basically to show that as we are changing the gas lift rate, we can clearly see increase in the oil rate from this plot, and then there is a decrease. But on the other hand, if we look at the time series, it's just increasing. What it means that when we are increasing up until to a certain point, the flow is gravity dominated, and it's actually injecting more gas lift to the system. It actually helps in reducing the density of the column. But as we increase it further, we see that it goes into friction dominated flow, so then it's giving less oil rate. It's not helping much. So that's why it's always important to find the optimum gas lift rate for the maximum oil production. In a way, based on this plot, we can see, and comparing with this time series, we can say that the optimum gas lift rate is between 2.5 to 3.3 standard meter cube per second. So this is one of the methods. Now we will go and try to look at the second method, which is to use a parametric study. When we go to the parametric, the first thing we see, I think I haven't explained it a bit previously, the external data, it basically means that if you want to read data from some source, it can be a sensor data from CSV file, it can be connecting to an Pi server, for instance, and then use those values inside the model. But we are not using it for this video or demo. Then comes the parameter. In the parameter, what as a user will define what are the variables, ranges of the values that I want to change. There are different sampling methods available, which are under this drop down: regular grid, individual parameters grid, latent hypercube, and you can also define it via CSV file. But for this purpose, we are going to use the regular grid. And under the next, we can add parameter definition. Under the parameter definition, you want to define what is my minimum value. I want my values to be changed for this particular parameter from this value to this value. There are different types of it available: equidistant grid, Gaussian distribution, predefined vector, uniform distribution. So we use equidistant. I have defined, I'm basically telling that I need 9 number of points between this value, minimum value, and this maximum value. So it splits them and run the simulation 9 simulation between these 2 points. Now we have defined that these are the values that I want to change, or at least this is the range of the values I want to change. In the parameter mapping, we will connect these values to the simulator, or what we want to change inside the model. So here under the parameter definitions, here we have defined that under the model I want to change, do the changes for this gas lift source, and I have defined it as GL, which is same name as GL here. We can add more parameter definitions here, meaning that we can use the same thing for other, or we can define more parameter definitions here as well. Different values, maybe for reservoir pressure, maybe for choke position, etc., etc. But in this one we are keeping the other things constant, and we are just going to change, just want to see the effect of changing gas lift rate on oil rate. In the simulator output, we can define what we want to output. So here I have defined volume flow, STC, gas, oil and water at measured depth of 0, which is at the outlet of the system, outlet of the model, at the wellhead. In the output method, there are different output methods available. The first one is average. What it means is that, let's say you have simulation end time of 3000 seconds. So what it does is that it takes the average of last half of it, let's say last 1500 seconds. Then the next one is one value. In this one it just reports you the last value. When the simulation is finished, it just reports you the last value. And in the entire list, what it does is that if we run the simulation, it will provide the whole time series, not the average, not the one or the last value. It will plot or produce the entire list for this given MD. But for the purpose today, we have used, or we will use, this average value. And all the, as I have mentioned previously as well, that all these changes that we do, it's then converted into in the text editor as JSON, which is then used by FLUX Applied to run the simulation as input to the optimizer, to the engine. Then we go to the run simulation part. So I have already run this simulation, so it was run on 24th of June. So in order to plot it, we need to go back in time, which is before the time when the simulation was run, in order to account for plotting these values. So we have gone to 23rd, and I will press the apply button, and in the scatter plot we can select what we want to plot. I will select parameters.gl. GL was the parameter that we defined here. Let's go back to 23rd of June, apply parameter.gl, and then we say that parameter versus oil rate at that we added in the simulator output. Press OK. Then we get a beautiful plot like this. We have on the x-axis the parameter, or the gas lift rate that we defined, changing 0.5, and it's increasing further. And on the y-axis we have volume flow rate of oil at a standard condition. We can clearly see that it keeps on increasing until a certain point and then starts reducing. So I guess here we have oil rate of 1.871 and 1.8745. so this is the maximum. So at 2.75 we got the maximum oil rate. So from the previous one I said that it's between 2.5 from the scenario 2.5 to 3.3, and now in this one we are getting closer. It's actually 2.75. it's between 2.5 and 3.3. And in the next step, which is then the optimizer will we will have a look at the third mode, which is the optimization. In that one, the optimizer will give us a single value. means that optimizer will give a value of oil rate, value of gas lift that gives the maximum oil rate. So just keep this number in your mind, and we will compare it with the optimization. So here we have 1, 2, and now we go to the third one, which is optimization. In the optimization, again, we have external data. It's basically, as I explained earlier, if you want to connect to Pi or some sort of other data sources, we can also connect to other modes if we want to. Currently, for the pure optimization, we don't have a GUI which is in the process, but currently we just define the input for the optimization in the form of text JSON. But in future we will have components similar to parametric study that we can use for a user without going into the text editor. They can select the components and define different settings. I will not go into many details about the different components inside this text editor, but I will go into the simulations and show you the results that I have already run. So again, it was run on 24th of June. So I would like to go to the date before that, 23rd, so that it accounts for that, and I would like to now plot the parameter that was changing, which is the QG lift or gas lift rate, and I will also plot the volume flow oil at MD0, which is the wellhead or end of the outlet of the model. When we plot the values here, you can see that what it's telling us on the we have the axis, x-axis for time, and then on the y-axis we have the different variables: volume flow oil STC and optimized gas lift rate. So here when it was run, so here we can see that what it's telling us that at 2.732 it gives the maximum oil rate, and if we compare it from the optimization or from the parametric, from the scenario we said that it's between 2.5 3.3, then we nailed it down further with the parametric, said that it was 2.75, and now it's clearly saying that the optimization has found a signal value and telling that at this gas lift rate 2.732 you have the maximum oil rate. And this is what I was planning to show you today, and hopefully it was helpful, and thanks for listening.